This is one of the guest lectures I'm the most excited about from the course I've been running this week, Systematically Improving RAG Applications. I'm very excited to invite Manav from Glean to talk a little bit more about enterprise search and in particular, fine-tuning embedding models. I'm surprised more people aren't doing it, so I'm very excited to learn more about how Glean is thinking about these kinds of problems. So feel free to just kick it off.
All right. Yeah, thanks for the intro, Jason. Excited to talk to all of you about embedding, fine-tuning, and how we do things here at Glean. My name is Manav. I'm a software engineer at Glean. Been here for about 3 years and primarily work on our semantic search and ML systems for search ranking and assistant quality. Yeah, so today's talk will give a little bit of an overview about what Glean is and our architecture, how embeddings play into our RAG system and the overall kind of ecosystem of what Glean is building. But then we'll dive in, dig deep into our language model or some of the practices that we employ for creating the best embedding model there is for RAG systems. So one of the main products we're building here at Glean is something we call the Glean Assistant. One of the main kind of unique qualities of Glean is that we take all your enterprise data across all your different applications and data sources, Google Drive, GitHub, Jira, Confluence, and we bring it all together and include world data as well to be able to generate the most relevant answers for you and any questions that you might have, and also automate workflows within your day-to-day job. By bringing together all this enterprise context and all these at these different application layers, we can do this in a way that no one else kind of uniquely situated to do because all of that kind of lives in one singular place in a unified data model that we create for each customer. And so this assistant that I just showed you is one component of the overall Glean Work AI platform that we're building. This expands to cover so many other different types of AI applications, thinking about like agents, search, and the agent builder, and so many different kind of orchestration platforms that we're building right now to make your day-to-day work so much more powerful and infused with AI at every step of the day. And every kind of workflow you have, you can think about finding ways to use Glean to automate it. You bring together the most relevant information, building workflows and tooling that can help make every single step a lot easier. And we have one of the best security and governance layers out there for bringing together all this data in a very secure fashion, such that there's no concerns about privacy or leakage or anything like that. We integrate with all the best LLM companies out there to make sure we can provide the most powerful system possible. This talk will specifically focus in on the self-learning language model, which is our embedding layer, the key component to our semantic search systems, which gives the high-quality search results that you need to build any of these workflows. So first, we're going to talk a little bit about some of the guiding philosophies that we like to adopt here at Glean from thinking about building enterprise AI. Search quality matters. You can't have a good RAG system. You can't have a good overall enterprise AI product unless you have good search, because there's always context lurking somewhere in your enterprise that you need to bring in order to do things correctly. And so search is the key component to making generative AI work in the enterprise. And if you don't, and you just pull together random information, you have less confidence about where your LLMs are pulling data from. It leads to hallucinations and a lot of confusion for employees, which could lead to a lot of business costs that you just can't have. And related to this is you need to have enterprise grade security as well. The privacy of your data when at the enterprise level is obviously super, super important. And you need to make sure that when you're building these data models, you're building your data governance layer, you want to make sure there's no risk of security breakages or data being leaked across different your customers you're working with or anything like that. When thinking about how you build your data layer and how you train models and deploy models, you need to make sure you're aware of the guarantee you want to provide to your customers and how that informs your technical architecture. And one of the kind of other key components here is that enterprise data is very different than internet data. Internet data has so much of a head problem where like everyone's looking for a lot of the similar things. You're either looking for like very popular websites like Facebook or Google, or you're looking for like very common source of information in places like Wikipedia, Stack Overflow, or things like that. So it's very easy to like model some of these things in more accurate and descriptive ways versus enterprise data is so much more heterogeneous and it's not super clear cut how everything fits into one singular mold. Like you have your basic document data sources like Google Drive, Google Docs, Confluence, and think Notion, things like that. But you're also working with a bunch of different types of applications like Slack, which is a messaging platform. You have Meetings, which doesn't really meet the standard not concept of what a document is. You have GitHub and Lab and all these different pull requests and change management systems that all behave in slightly different ways. And you want to be able to bring a single unified model for all these different types of applications. And to do so requires a very robust and generalized unified data model that makes modeling things a little bit more complex. But it's important that you understand those nuances in order to build very performant enterprise AI systems. And when working with that, that's why the concept of generalizability also becomes really important. When you make enhancements that to like any kind of piece of your product, you want to make sure they have impact in all the different application layers that you're working with and impact the different layers of like your enterprise AI system. And so one way you can kind of think about it is we have Glean Search, which is the foundation for most of how our systems work. They have the Glean Assistant, which is the simple RAG platform, which uses Glean Search to power the answers it generates. And they have the Glean Agents layer, which kind of uses RAG and uses the assistant capabilities to do even more complex things. And when you're thinking about making improvements, you want to figure out how things work across the stack, all the different applications you're building, because they all are going to be slightly intertwined together. And you want to make sure you can deliver the most amount of value for the changes you're making. So what this results in is a few interesting technical implementations about how we build RAG systems here at Glean. So in terms of thinking about having the highest performing search quality, company-specific language matters a lot. You have so many company projects, initiatives, and like fund service names and things like that that you want to make sure your language model and like your search system understands really well. And if you don't, you're not going to have performance search. So making sure you take into account company-specific data and company-specific language is like really important for building enterprise AI. And related to what I mentioned about heterogeneous enterprise data, having that enterprise data modeling, a scalable data model that generalizes to these different classes of applications becomes really important as well. And I think a lot of the focus has been these days about building the biggest and best LLMs and like embedding models. But when you're thinking about building like really performant enterprise AI in working within like single customer deployments, given like security and privacy constraints, you want to also think about using smaller embedding models for when you can. And because small embedding models, when fine-tuned to the domain and the specific task you have in hand, can give you a lot better performance compared to just using large LLMs. They're super general and don't necessarily work well for the specific application that you're working on for a particular customer. And so that's why thinking about using small models when they make sense and when they're better performant is like a really important technical detail to get into. And obviously, the majority of this talk is going to talk about how we do fine tuning at the embedding layer because that's just how you get really good semantic search. Because you need to have that enterprise context injected into your embedding model if you want to make semantic search systems work really well for the enterprise. And a key way you can get to this is by doing a lot of synthetic data generation, which we'll talk a little bit more in a bit. But specifically for like small customers and small corpuses, using synthetic data can be really impactful for building the next level of like high quality search systems. So yeah, let's talk about fine-tuning embedding models. Glean builds custom embedding models for each one of our customers because each one of our customers is very different and unique and has their own sort of dialect for how they talk about work and talk about projects at work. So the start here is like we always take a base model, very high performant, like general embedding model, things like BERT-based models that have like, shown to be done really, really well in general language understanding. But if you want to make that into a company-specific model, you need to do some form of continued pre-training on company data in order to make it go from a language model to a company language model that really understands the nuances of your company. But companies change a lot over time. The new projects come up, new initiatives come up, old things die out and no longer become relevant. And you want to make sure your language model adapts to the differing needs of a company over time. What the company, for especially for like a really fast-growing startup, what your company looks like now will look very different from a year from now. And so you want to make sure your language model is constantly evolving as the company grows over time and learns from like user feedback, learns from as new projects come up and new documents come up, new applications get introduced, etc., and make that a really core part of like your model training system. One data point we've seen is like after 6 months, you can see like a 20% improvement from our overall search system just by gaining, like by learning from user feedback, adapting to the nuances like, of the company as it grows over time, etc. If you were to have the most relevant enterprise AI model, you need to be constantly learning from your users. So the first step I mentioned was this kind of step of continued pre-training to really learn the nuances of the company's dialect. And the way we do this at Glean is we use mask language modeling. Mass language modeling is a tried and true technique that has been extended for like many years now, and I think is still one of the most powerful techniques out there for adapting a language model to a particular domain. I think tons of research has shown the impact of this on any continued task after that you fine tune afterwards. So the first phase of training we use is uses mass language modeling to convert a general language model like a BERT-based LLM into a company-specific language model. And what you do is you take sentences from the corpus, you blank out certain words, and the model's goal is to learn how to fill in those masked words in order to complete the sentence. And doing this task requires a pretty nuanced understanding of language, both like general English language, but also company-specific language, especially if you like use techniques to improve the quality of your masking to specifically mask out words that are more specific to that domain to ensure your language model learns that domain understanding a lot better. This by after like, and this is like such a useful and powerful technique because everything in the enterprise is data that you can use to train on, and so like, you never have a shortage of data that you can be learning from. And so, if, no matter the size of the corpus, you have plenty of data to really do this type of domain adaptation and get yourself started on building company-specific language models. Now that we have a company-specific language model, we want to go from like a language model which into an embedding model because we're interested in building semantic search systems. And just using mask language modeling, it doesn't really improve the quality of your embeddings of your model for the specific task of search. You get embeddings, you get token embeddings and things that you can use, but it's not very clear if they will perform well on search related tasks. If you want to make sure you get good performance there, you need to train your model on the task specifically. And so a good starting point for thinking about how you can train a model using pairs of data to train and to convert your go from language model to embedding model, it requires doing a lot of unsupervised learning in some sense because you don't have a ton of user data that you can use to train embeddings. So here are a few techniques that we use to kind of bootstrap this process and get started. So one example of a data set that we create is something that we call title body, which takes titles of documents and maps to the body of random passages from the document, which can be like a really good proxy signal to just learn more about the company because you can just read almost every document and you can gain a lot of useful information that way. Obviously, it's not going to be the most golden signal out there, but it gives you a good starting point for just learning things that are somewhat relevant to each other because titles of documents tend to be relevant to the passages in the document. So another useful source of data is anchor data. I think one of the most useful things that Google's ever done in our PageRank is understand that connections between documents is how you can determine relevancy between the documents and understand the relative importance of documents in the company within the world. And the same exists at the enterprise level as well. Documents that reference other documents are probably slightly related to each other. And so you can use that as a signal for learning relevant pairs of data. So you can take a document that references another document and take the titles of those documents as pairs because those titles are probably relevant to each other. So a lot of different design options here about how you can use anchors to create pairs of data for embedding fine tuning, but it's a very rich and powerful source of data that you should definitely be leveraging. Another interesting source of data that we use is something we call co-access. So oftentimes when people are digging into a research topic within a company or want to learn more about a particular area, they'll visit a bunch of documents all at once about that topic and try to learn as much as they can, diving deep into the various nuances and history around that area. And so when they're doing that, you can get a really good signal that all the documents that they're visiting in this like short period of time are probably like somewhat related to each other. And so that's like an easy source of signal you can use for training, creating pairs of data for training your embedding model. Like you take the titles of the documents that they visited within that short time window by the same user and create positive pairs from that as well. And so those are good ways to get a ton of enterprise signal to convert your embedding model into a good company-specific embedding, or your company-specific language model into a company-specific embedding model. But there's also tons of work out there that's been done on creating very powerful, high quality public data sets that you can use to train embedding models. And it would be silly to not take advantage of those as well. And so one thing we also do is take these public data sets, things like or question pairs, MS Marco likes data, or it just has been used to create tons of really high powerful embedding models to train our model as well. Because if you're training, especially if it's working on only English only customers, then like that type of English data is also still really relevant for training like the best embedding model out there. And you just want to make sure you have a good mixture between your company specific data and like these general English data so you don't have any catastrophic forgetting problems. But I think mixing the two will often give you the best performing model possible. There are a lot of nuances that come with building these types of unlabeled, unsupervised data sets in the enterprise setting because of the heterogeneous nature of enterprise data, as I mentioned before. And you want to really make sure that when you're building these data sets, you take into account the nuances, the different applications you're working with to make sure your data is really high quality. Because one of the most important things with training models is making sure you have high quality data. And if you don't really understand the nuances of the particular applications you're working with, you might accidentally create a bunch of really bad data pairs that aren't useful for training. You just end up burning a lot of compute cost and you get a bad language model. So here are examples of ways that you need to think about your enterprise applications a little bit more in detail before just going in and using these unsupervised training techniques to create pairs from. So for example, with Slack, There's a lot of different nuances how you can think about modeling Slack data, and that are different from the traditional sense of what a document is. So in Slack, the bit naive notion of building a version of Slack message as documents is to take each message and consider it as a document. But there's a lot of problems that kind of come with that notion because a lot of Slack messages tend to be really short, don't have a ton of context, and only really make sense in the context of the broader conversation happening around that message. Right? The individual message itself might not say much or might not have enough information to really learn anything super meaningful from. And they don't have titles, right? They're just all they have is like a body of message. And so the title body example I gave like doesn't really work in the case for Slack. So like you can either like be aware of that and just not use Slack data when you're building title body, or you can find other ways to be creative and you convert Slack into title body pairs. So one example is like what we do at Glean is when we're thinking about Slack, we don't just think about each individual message as a document. We want to take into account the broader context in which a message is sent and create conversation documents based on that are comprised of individual messages. So there are a lot of easy heuristics you can use for that. Like for example, like threads is a very big important notion in Slack, and so you can just take like the entire thread and model that as a single document. But oftentimes there are a lot of channels that don't use threads at all, and you can just take maybe messages that occur within a short time span and you convert that into a document as well. And then once you have that document format, you can think about, oh, what if you just use the first message in a conversation document as the title, and you can use the rest of it as a body. And now you get a bunch more data that are more specific to the application that might be higher quality compared to just like either excluding the data or just using individual messages. So that's like another good example of how understanding the application layer of your what your enterprises are using, what your customers are using, is really important to create the best data possible. Not all messages in Slack are super important. Most companies probably have random channels that kind of talk about literally random topics. You probably have a happy birthday channel. It's not super useful to train on a bunch of happy birthday data. And so you really want to understand the nuances and the specifics of how your customers use the different applications to understand how you can mine the most useful and effective training data possible. And depending on the security agreement you have with your customers, this might get really difficult because you might not be able to look at their data when building these data sets for training, because obviously no company really wants some random person reading all their company specific documents, because that's obviously a very big privacy and security issue. And so your best way around this is just ask a lot of questions, get to know your customers, understand their behaviors, and gain a lot of insights as possible, see what things are common across the different people you're working with, and try to build heuristics and processes that are as generalizable as possible across the different applications. Having a unified data model helps a lot with that, but understanding the specifics of each application and how you can fit each application into your unified data model is like one of the most tricky parts, but I think is something you really need to do if you want to build the best data sets possible for training. There's no alternative to getting your hands dirty, talking to customers, and understanding your data for when you want to train models. One of the other main powerful sources of data you can also leverage is synthetic data, especially for really small corpuses that might not have a ton of documents to be able to leverage, and you have like a little bit more concerns about the quality of them. LLMs are super powerful general systems for being able to understand unstructured document data, and they can help you a lot with creating better training pairs. And a simple approach to this is you can use an LLM to generate a question answer pairs for various different documents and message data in your corpus and use those as label training pairs. There's a lot of nuances that come to doing this right because you want to make sure that there's a lot of LLMs by themselves. If you don't give them really proper instructions, will generate things that make sense to itself, but it might not be super aligned with the goal you have in mind. And so you want to make sure if you're doing like a prompting based approach, you give clear instructions to your prompt to ensure that the questions you generate are similar to what you expect users to actually ask. For example, if you take like a sentence out of context and you just ask an LLM to generate a question, it'll typically tend to generate a question that like basically matches the entire phrasing of the sentence that you're asking about. We'll just add like question words to the beginning. And that's not a super useful training example to use for a semantic search system because like you don't want to learn just like exact lexical overlap. You want to learn semanticness because when your user is asking about that exact same piece of information, they don't have that document in their right in front of them when they're thinking about how to ask this question. They're just thinking about things very generally, might leave out a lot of words, might use different language, might use acronyms, and you want to make sure that your LLM is thinking about things in the same way when you generate these question and answer pairs, such that they match your exact user outcome, your user use cases more directly. And you want to make sure you take into account the different types of use cases that you might have within your RAG system and not just focusing too much on one particular type of question. because LLM generation can be quite costly depending on the size of the corpus you're working with, it's important to maybe filter down to using the most popular documents in the corpus so you learn the most relevant information for each one of the customers and not just focus on random documents that might not be as relevant. Because you like even though the main goal of this might be to learn like semanticness and with general question answering embeddings, but you also are going to learn information through this process that help inform the quality of your company specific embedding model. And so you want to make sure if you are doing that, you're gaining the most relevant information. And that's why kind of building a big, powerful ranking engine on top of everything like that is able to understand what documents are popular and which ones are not is also just really important and what makes Glean uniquely powerful. Yeah, so this can be like a one-time expensive approach, but you can get you the infinite data that you need to really train high quality and powerful embedding models. And it can be super impactful for tons of customers that don't have a ton of user activity or might not have a ton of documents that you can use to train for them, but it can get you really close to what the maximum amount of trained data might need to get a high quality embedding model. It'll never actually be the same as what actual users might be asking, but it's probably about as close as you can get, given you don't have any user signals in front of you right now. But once you have feedback and user signals from that base as they use your product, that's going to be one of the most important signals that you can use to improve the quality of your embedding models. So at Glean, we have a search product, which is a super popular original product that we originally came out with, and users love it and it's super useful for finding navigating through documents, doing a lot of question answering, looking for the most relevant documents related to you or particular topics. And so when people are searching for things and clicking on things, those are like very easy signals that we can mine from to improve the quality of our embedding models by just using query click pairs. And so having search as like a product has helped us a lot improve the quality of our embedding models because it's directly related to how users are asking things. And that as the closer and closer you get to training on user data and user-like data, the higher quality your system is going to be to your users. But in a RAG only settings where like you might like for our Glean Assistant product where no one's really actually clicking on documents or anything like that, it's a little bit trickier to think about how you can learn from user feedback. The user is either like satisfied or dissatisfied, and you have no clear indication of that unless you have like some type of like upvote downvote system. But even when you implement something like that, users will be like pretty hesitant or to use it, and it'll be like a very limited set of users who actually like upvote and downvote consistently. And so you're not getting a ton of good signals for about how you can improve the quality of your embedding model or the quality of your system overall, because if you aren't getting that relevancy signal directly from your users. And so this is like a pretty hard open question about how you can learn from user feedback in this like RAG only setting. And there's no clear answer that I can give you right now, but there's probably a bunch of ideas out there you can think of that are all pretty sparse. But over if you do a bunch of sparse things, hopefully you can collect enough data to be able to get some useful signal out from your user feed from your users that you can use for training. But you can also develop other proxies based on the interactions that your user has with your product, and making your product more interactive can help gain those signals. For example, if you have like citations in your system because you want to reference like where your answers came from, which documents you're using when you generate a response, you can see which users maybe click into certain documents wanted to read a little bit more about the topic. And that means if they do click on those are relevant documents that are related to the query, so you can get positive pairs based on that. It's not going to be a perfect signal, but having a bunch of weak proxies that you can average across all the other data sets that you're building will definitely help a lot in building the most powerful system you can. All right. So we talked a lot about building custom embedding models, and there's a lot of different things that you want to also evaluate on your own when building your own embedding systems for your customers. But in order to know if you're moving in the right direction, it's really important to understand and under how you can evaluate your embedding models in a systematic way to make sure that changes you're making are beneficial overall for your customers. Having a rigorous evaluation system to understand whether your changes are good or bad is like just really important to giving your users a consistent, high quality product experience. So one thing we do here at Glean is we've invested more into automated quality evaluations that are tailored to different types of query patterns that we see within our users. Evaluating RAG system end to end is a complex task because there are so many moving parts. Like at the very basic core of it, you have both your search system and the interactions with the LLMs. You might have a query planning module, you might have a summarizer that takes your search results, outputs them to your users, and you're anchoring on a lot of different components in terms of understanding if your end-to-end RAG system is doing really well. But you want to really focus on individual components sometimes and think about how you can improve those individual components and optimize against a more specific metric instead of just thinking about the end-to-end system overall, because it might be too hard to evaluate things end to end all the time. And even just for the embedding model layer, it's also really hard to understand whether a model does well or poorly. And it becomes particularly challenging in the enterprise setting where you don't have access to your customer data and you have enterprise specific models for each of your customers. So if you have hundreds of customers, you have hundreds of models you need to think about managing and thinking about how you can do a robust evaluation for all those different models is definitely a very complex task that I don't think there's one solution out there for. Because in the research setting and the academic settings, you typically build one model for everything. But I think the gains you get from building company-specific models is so huge that you just can't let yourself not do this, even if it's a really hard problem. And so one way we tackle this at Glean is we build unit test. We unit test our code, but we also unit test our models in a lot of ways. An example of this is like you want to pick out behaviors that your model that of a model that you find desirable and build an eval set for them and make sure a model is doing well on that particular type of query stream. For example, a good semantic search model should be really good at paraphrasing. Understand that paraphrases of the same sentence or a particular query actually mean the exact same thing. So you can take examples of queries or existing data sets of paraphrases of sentences, or you can use LLMs to create more of them on your own. But the main idea is like you can take these data sets like paraphrase examples of text and make sure your model is doing a good job at understanding that those paraphrases are really similar. And you should have some target goal in mind for each one of your custom models across all your different customers for how well they should be performing give on this particular type of like query pattern. And if the model is like underperforming, you can investigate a little bit more, hyperparameter tune the model, think more about how you can improve the quality of your data, other things that make sure that you can get to that quality bar that you want to make sure you get your customers getting the highest quality experience possible. And if you take this more focused approach to evaluating your model, as opposed to evaluating quality in a holistic general sense, it's a lot easier to build a much more scalable evaluation and understand where you should be dedicating your time towards improving your system. And you can identify which customers are having poor experiences before the customer even experiences it, because you have this robust set of unit tests to understand like where the state of their system is right now, and maybe gives you some insights into what you can be doing to make it better. All right, I'm gonna end now with some closing thoughts, summarize a lot of the kind of different points we've got into so far. So, a few things that we've learned while building fine-tune and embedding models within enterprise and just building enterprise AI overall is that having a unified data model is just a critical. No matter how complex the problem becomes, being able to map things into this unified model is just super, super important, and is the only really scalable way to like take advantage of all the different components that exist in an enterprise setting. You want to leverage all the data you can, given that there's so much data in enterprise AI, and building that unified data model is a key step to getting you there. And once you have all this data, you do want to get creative and figure out how to generate the most valuable training pairs possible for training your embedding model. Like synthetic, we talked about so many different strategies for that you can use to get, but there's plenty of other ways that we haven't talked about yet, other ways that we haven't explored yet. That are also going to be super useful for creating better and better embedding models. Learning from user feedback is valuable, but also sometimes sparse, especially depending on the setting of the product that you have. But if you can find ways to learn from user feedback, you'll get a ton of value. And I can never underemphasize how important it is to understand the user goal and the user journey. And at the end, when training models, even if ML feels like a math problem, it's all tied back to the user and being able to connect it and understand the user journey and how they ask questions is always going to be the most important component of building a really high quality search system. And you should focus your ML modeling in that same vein as well. There's so many different types of queries that users are going to ask, and it's important you understand and know all of those kind of beforehand. Talking to customers, talking to your users is really important because you want to understand the different types of queries, understand how your system is performing on them individually, and build this kind of scalable unit testing framework I mentioned in order to understand how you can get better and move on to the next level of performance. And isolating and improving individual components of your RAG system altogether is always going to be the best way to move forward. You obviously still want your integration tests, you still want end-to-end testing of your overall RAG system. But if you want to really make good, tangible progress, like day by day, isolating and optimizing individual components is always going to be like much more scalable than trying to improve everything altogether all at once. Thank you for giving me the time to talk to you all today. I hope you found this super interesting and useful. And now I'm going to open to you all for questions.
Especially even the title body thing now seems very obvious. Cool. Let's go over some of the questions from Slido first. Maybe we'll do like, we'll see what the time is, and then we can maybe do some open questions if we have time at the end. How does that sound?
Yeah, sounds good.
Perfect. The most voted question was, how do you evaluate the quality of search for your customers, especially since Glean doesn't own the customer data and the relevant chunks might span many documents? I guess to add to that too, I think You mentioned after 6 months, users see a 20% performance in that. Like, what does that performance look like? Is that the same kind of performance that you track?
Yeah, so I guess there's different types of evaluation we're looking
Mhm.
at for different product use cases. For like search, the main thing we look at is this notion of like session satisfaction. Like essentially when user asks a question or they start searching for something, like what percent of the time do they find a relevant document based on their click patterns? Ideally, like all these sessions end with a click, and that's like how we measure satisfaction. Sometimes clicks are good, sometimes they're bad, and so there's a lot of nuances that comes with understanding the quality of each. Ideally, like a user clicks on a document and they read it for a really long time, and that means they probably found something super relevant to them. But that's the general idea for how we measure the quality of like our search system. And at least at like the user level and like online metrics. And for assistant, we also look at very similar signals, where like if they're asking a bunch of questions, as the usage goes up, that means they're finding the experience more and more enjoyable. They're finding value out of it. And if they're upvoting things a lot over time, like upvotes are like a very small, sparse signal, but if you can see that trend increasing, then you know you're definitely doing something right. And yeah, we also have downvote systems. We also want to make sure people are less angry and less upset about the responses that they're seeing. And so if downvote rates are also going down, then you also see we're making pretty good improvements. And that we can use to see if, oh, are we performing better compared to what we were doing previously? That helps us understand if we're improving our product every time we make a change.
I see. So most of the time, when you're looking at the search quality, you're really just able to look at business outcomes instead, right? So are people clicking things, time spent, rather than obsessing over like just the recall in the offline sense.
Yeah.
To follow up on that, like how much do you guys think about things like LLM based like judging type capabilities? I think it's been a pretty big debate in this space whether or not like factuality or correctness or like context recall relevance are things you spend a lot of time thinking about.
LM judge systems are super, super important, especially when thinking about working within enterprise data because of the fact like ideally you don't have the time, you don't want to, and there's security guarantee reasons where you can't look at your enterprise data. But if within like a closed loop environment where you use an LLM to judge the quality of your responses, you can get a lot of useful signal out of that for understanding if you're making improving things. For example, you can do a simple A/B test. You ask 10 questions, hundreds of questions based on what users previously asked, and then with you using your old system and then on your new system, and you have the responses from your system at the end, and you can use like a simple judge framework that broken down based on these different subcategories you mentioned to see if you're improving on each of those different dimensions. Because you definitely want to have like different kind of components in there when understanding if you're improving your system, and it's super powerful. I think there's definitely a lot of like noise that you get with these things because relying just on like different LLMs for as your judge, you never know how consistent they're going to be with their different responses. Even if you give it the same input, sometimes it might say it's good one time, it might say it's bad the other time. And even LLMs are pretty brittle to the paraphrasing problem. Right? You could just change up one sentence in your final output, and it might go from good to bad, even if that sentence is not super relevant. But I think once you have high quality judges in place for these different dimensions of like user quality, then you can definitely, you should, and we can use them pretty effectively for scaling your evaluation process.
Am I hearing you right that you said that you use A/B tests to generate the labels for your judges?
No, it's using the judges in that A/B testing setting.
Okay. I think you somewhat answered this, but maybe we'll just go over it since there's so many upvotes. Can you explain the flow of identifying company-specific language? I think they may be talking a little bit about the token embeddings and the masking, but can you talk a little bit more about that?
Yeah, so like identifying company specific language is like hard in some sense where like you don't know yourself like what's specific to a company, what's not, especially if you don't work there. The main idea there is that through mask language modeling, your language model will be able to identify and pick up on patterns that exist within the company corpus. It will just understand how language is used generally within that corpus. And so it picks up on those different patterns and knows what company specific language is. And at that point, after your model is adapted to the domain, like, it doesn't really matter what is and what isn't. It just knows this domain really well. And so you don't need to like, there's some things you can do at identifying like particular projects and concepts that are important in the company. But like the ideally your language model, like through this mass language modeling and do all this pre-training work, should just understand the nuances of your company language. And that kind of propagates throughout the rest of the training process as well.
I see. How does Glean fine-tune the embedding models for each customer? Do you always start with basically a Glean base model, where then you train some kind of adapter for each customer? And what kind of models have you been looking at? Do you use things like modern BERT, or do you use a different kind of architecture?
Yeah, so we still use a BERT-based architecture. It's a pretty tried and true system. Obviously, there's a lot of new updates and research that comes out, and we take advantage of that where we can and where we think it makes sense. But yeah, that's in terms of base model, it's like the overall architecture. But yeah, we do fine tuning of the layers that we think are most important for understanding the enterprise to gain that enterprise context. There are different scalability challenges that come with various different methods. Adapters are really good because if you have a ton of data and might not have a ton of compute, then you can like more easily train on like larger data sets. Especially if you're like using really big models, if you use smaller models, you don't necessarily need adapters as much because you can train the whole model end to end a little bit more easily without having as much compute, even if you have a ton of data. So it depends on what different constraints you're operating under, and you can operate in different ways. We try to be flexible and update our system overall as like trends change, but that's the overall general pattern that we follow. Like nothing too complex.
I see. I see. Yeah, I guess when I was doing a lot of these like fine-tuning jobs, we were running things on like a weekly basis. But here, like, how do you determine when you want to be rerunning these fine-tuning jobs? And also, just from my curiosity, how do you make sure those vectors are stable? I doubt you're re-embedding everything every time a model is trained, but could you share a little bit more about what that looks like?
Yeah, so we do things on a monthly basis. I think it does really just depend on the company whether or not that makes the most sense or not. And because you do this pre-training step, like even if there's like a ton of new documents that are being created, unless there's like a ton of activity happening, it's like you could probably loosen that constraint a little bit more because I think it's very rare when a brand new concept appears and becomes super important in the company, like over just the span of a week or even a month, depending on the size of the company. And so you can like tune like your freshness constraints based on that and like how the company behaves. And yeah, in terms of vector stability, it definitely is a hard problem to understand. I think what I've noticed based on some of just experiments I've done, I think there's like a decent amount of like stability in terms of model outputs like across different training runs, but it's obviously definitely not the same model. So you definitely want to have a good system for being able to update the freshness of your vectors and your semantic search system. Because yeah, if your model does change and that freshness constraint is important to you, you have no way around it, or else the quality of your embedding search is going to become a lot worse over time if you don't reindex everything.
I see. So we're not rotating pre-existing vectors. We're just going to be re-indexing everything on a monthly basis when new vectors come out or a new embedding model is
Yeah.
produced. That makes sense. To what extent do you guys think about things like image embeddings and videos as well? I'm sure there's a bunch of like PDFs that are hard to process and there's like diagrams in there, but that's also going to be images and videos. Maybe even talk a little bit more about like Colbert or not Colbert, Copoly, for example. Like, not sure if you guys think about those kind of things, but I'm curious to hear your answers.
Yeah, so PDFs are probably the main source of like images or image-like data that we have in the enterprise. You don't have a ton of images or like image search like things like you might have a search for a similar picture of this in Google or something like that, or like you don't have a photo library that you're searching across in most enterprise settings. There's a variety of different like pretty powerful out-of-the-box tools you have for PDF parsing, and we mainly leverage those. But we primarily work in the textual space because that's just where most enterprise data lives.
And then I guess another question I think many people are asking about is like, how do you think about things like access control? I think it's one thing to say we have a different index and a different embedding for every customer, but then there might be things like documents that are only accessible to certain VPs or documents that are only accessible to certain teams. Are those going to be separate indices? How do you think about things like having exhaustive search or perfect recall in some of those situations?
Yeah. So our main search engine that has all this ACL information at the user level. And so no matter what, even if you're like training models or anything across most documents, you can always still filter those out by using the ACL system that we have within our open search based search engine. And that's solved a lot of those issues. But we do still take into account the concepts of privacy and what to a decent degree when training our model because we don't want to train on documents that are like purely just private to particular users and things like that. They're also like less useful documents in a lot of sense because if only one user cares about this document, like the bang for your buck that you get from training on the document is like very low. You get a lot more value when you train on documents that are accessible to everyone or documents that are accessible to like very big departments within the company. And so it's just like thinking about so having that we have that permission granularity already, and so then you can optimize your training signal based on that.
I see. And then it sounds like maybe the answer here is like access control is like post-filtered for embedding search, but might be pre-filtered for something like lexical search. And there's some sort of combination that you do to manage both of them.
Yeah.
All right. Let's go over some of the questions. Are there any questions you feel like we haven't asked but should be asking? Let's see. Yeah, I think many of these questions have been adjusted. Yeah, let's actually open it up for some live questions. We might have time for one or two live questions. Let's,
Yeah.
if you want to like raise their hand.
Thank you for the talk. Can you drill down a little bit more on that company specific language model? Are you talking about taking like 4.0 or something and then fine-tuning it? I'm just trying to understand what do you mean by that?
Well, so we specifically were talking about like the embedding model. So like we're talking about like
So this is only for embedding model,
yeah,
not for language
yeah.
model. Got it.
Navneet, do you want to go for your question?
Yeah, I just have a question like how do you handle like creating those unlabeled pairs at scale, like working with hundreds or thousands of different companies, right? Is there a specific framework you use for each company, or do you fine tune that framework as well? Like these are the titles and this title is linked to this thing, or getting sources, that corpuses you were talking about.
So I think that's where having a unified data model is really useful, right? So as we build connectors to different types of data sources and applications that all of our customers are using, we have a pretty good general sense of like how these applications, what these applications look like by the time we start processing them as the ML team, because we work with the unified data model as well. And so that solves a majority of the issues that would be hard for doing this type of unsupervised extraction. Yeah, so then there's obviously some nuances you still will want to think about, and like understanding the different data sources is useful for that, but it's not too hard. And then scaling up to like process like hundreds of thousands or millions of documents, like there's a lot of powerful frameworks out there that you can use, Beam-based or Spark-based systems for distributed data processing.
I love that things are still on Spark. Jan, you have a question?
Yeah, Manav, could you expand a bit on how exactly you use this unified data model? Because unified data model, I imagine, is like in a SQL database, but how do you connect that to documents and texts,
But
and
when
how is that used?
So when we talk about the unified data model, like it's the main thing we're talking about is like the schema itself. Like what are the different parts of a document that when you like think about indexing content from a particular data source, and how do you map those into a standard format so that you're not working with all because we're not building a federated search. We have a single unified index that kind of takes together all the different types of information from all these applications. And so you want to have the same schema for each of those things and find like a proper mapping and modeling of each of those applications to this like Glean style document. And that's what I mean. So like obviously that can map to like a SQL table schema as well, but the main component is like understanding the different parts of a document in like a unified and consistent way.
Okay, so it's not a data model like you have a customer, an order, payment, and so on. That's not that type of data model that you are talking
Yeah.
about.
We're talking about like overall like structure for how you like organize a document.
Okay, yeah, thanks.
Let's do Nathan's question, and then Abhinav has a question in the chat.
Do you guys do any sort of agentic flows? And if you do agentic flows, how do you measure retrieval performance for agent queries versus user queries? And what does measuring the evaluation between those two look like? And how do you handle the training, the differences? Do they start from the same root model? Things like that. We're trying to decide how to differentiate those.
Yeah, so we do have an agent system and that we're investing a lot more in as well. It's really hard to understand and break down the evaluation of those things, especially if like you have custom agent flows that like customers are creating. One thing we're investing is like this concept of agent builder, so you can create your own agents. So it's just important to have an understanding of your core embedding model and in your core search system and try to use that in the different ways that users are expecting. So if users are trying to build like a type of agent flow that requires like using search in a particular way, it's important that we're aware of that and can proactively like, make sure our search system is capable of handling those types of queries. And as we see those things more and more, we like build new eval sets that are targeted towards those particular use cases. It's hard to be proactive because you never know what your users are going to do, which is why as we build these systems, it's important to get in front of the user, ask them all these questions, understand what things they really want to do, and proactively invest in building better versions of our system that are capable of handling those.
Fantastic. Thank you.
All right, we'll do one question from Abhinav because I think this is a question that I've heard many times, and there's many people who have different answers. How do you handle old documents that are present in company docs but are irrelevant because they've been superseded? So I think it's a little bit about relevance and freshness, but it's also about sort of how things are updated. Many companies that do memories, for example, will have an example where it's okay, April, Jason cut his hair, then like in July, the hair is blue and now it's green. Then when you do a search, you got to figure out like, do you reason around this time component, or do you mostly think about it as a sort of traditional search engine and you just have like freshness or relevancy and recency?
There's a lot of nuances that go into like how we do this well. But yeah, so relevancy and freshness is like one kind of really big component. Overall, we model this as a concept that we call it authority. And so there's a lot of important signals that go into like understanding if a document's like authoritative to our particular query. And so like time is like one big one. It's if a document's really old, hasn't been updated in years, it's probably not the canonical source of information regarding a particular question anymore. But then you also think about, oh, has it been talked about in other ways? So going back to this anchors concept, if a document has been used to answer the questions around this topic for a really long time, we can pick up on those signals and understand this document is that source because everyone keeps linking back to it, even if the document itself hasn't been updated in a really long time. For example, like our Wi-Fi password, like that's a really old answer. I don't think we've changed it in a really long time. But the document that contains it, like, is still a really relevant document if you ever want to reference it, but that what the Wi-Fi password is, because people, anytime someone asks, like, someone will point you to that document, or you'll search for that document, you'll click on it, and like your user will be satisfied with that search. And so understanding that there's other kind of signals just beyond time itself is really important. Understanding how users are interacting with the document gives you a good sense of authoritativeness. And that, I think, is the most important thing for kind of distinguishing between old docs that have been superseded and new docs, and old docs that have stood the test of time.
I see. So I guess I want to ask the last question because no one has raised their hand. Given that model, if I was building this pre-LLMs, what I might think about is maybe I have the cosine distance as some embedding model, then I have maybe some recency feature, and then I have some kind of cohere ranker score. And then you have authority in all these other documents. Is it basically, does it look like XGBoost learn to rank? Or are there more modern LLM based techniques that do this kind of scoring? Because in my mind, it just feels like a learn to rank problem and like a relevant, and then just doing a search engine. But I'm curious if there's any new information in the post ChatGPT era.
Yeah, no, traditional learn to rank like systems do really well. And you don't want to over index on like semanticness or like LLM based scoring as the only thing that your search system should use for answering, finding the most relevant documents to a question. But honestly, you can get a lot more bang for your buck by not using any semanticness at all to answer most questions, because there's a lot of really easy ways to answer questions, basically using a very traditional lexical IR system and just using time as a signal. Because most questions, like for 70% of user questions, in the enterprise, it's probably like closer to 60 or 70% in terms of how easy this is compared to like web search. But by just using very basic signals that like you would use like a traditional search engine as well. And only when you want to get further beyond that and understand you have more complex queries, especially what we're seeing in like agents world, then that's where adding these other things becomes more and more useful. But using traditional based like search techniques and using these like traditional signals is super, super important, and it'll never be outdated. And any system that doesn't use that is like a questionable search system in my mind.
I think that's a great way to end the session. I think there's a lot of Twitter discourse. Can you build a RAG system with just full text search? And I think what I've heard and what I've said to many people is like 80% of the way there is just full text search, and then semantic search and everything else is the cherry on top. Manav, thank you so much for this talk. I think it was like probably one of the best ones I've heard so far. I'll do my best to get this up as soon as possible. I think this is gonna help tons of people give more clarity on what they're working on. I think we've helped a lot of seed, Series A companies tackle these kinds of problems, and this is where I think everyone is trying to get to. And so that's very exciting. Thank you so much.
Yeah, of course.